All right. So security is a hot topic these days, especially after the recent breach at LastPass. So we've got quite a good security track for you guys, and we wanted a really, really good security keynote. So who do you invite if you want a good security keynote? You want the guy who wrote the book, the guy who knows it all. Please give it up for our keynote speaker, Bruce Schneier.
Hey, good morning. I guess we all get to stand. You all seem used to it. That's good. Well, thank you. Thank you for inviting me. Everybody in the back, coming in the back there. Wow, hi, everybody. You look like more people when you stand. So I want to talk about data. I want to talk about security. I want to talk about surveillance. And I want to be very general and then go specific, really talk about what's going on in the industry and the world today, because I think it's important, and I think we all have to start paying attention to it. So the way I think about it is that data is a byproduct of the information society. I mean, everything we do on a computer involves creating a transaction record, right? Whether it's browsing the internet or making a phone call or paying for something, anything but cash, getting a medical test, walking by any of the millions of cameras, tens of millions around the world. Everything we do produces data. And the data is a byproduct of all our information society socialization. So our phone calls, our emails, our text messages, our Facebook chatter, all of this generates data. This data is increasingly stored and increasingly searchable, right? This is Moore's law at work, right? Data storage drops to free, data processing drops to free, and it is easier for us to save everything than to figure out what to save. I think of my email. I look back at my email when I was writing my last book, and I used to, in the early days of email, sort my email very carefully. I'd have dozens of mailboxes, 50, 60, each for a different person, different project, and I would sort my email accordingly. In 2006, I stopped doing that. In 2006, I started putting all my email in one big email box. Because for me, for email, in 2006, search became cheaper than sort. Right? And that line has kind of been crossed with pretty much everything we do. And if not now, it soon will be. What this means is we're all leaving this digital exhaust behind us everywhere we go throughout our lives. And you need to understand it this way because it's not a question of malice on anybody's part. This is just the way data works. We produce it, and now it's easy to save, so we're saving it. And our nature of data use has changed. Traditionally, pre-computer, we would save data for historical reasons. We'd save data to remember what we said or did. We would save data to verify our actions to some third party. We'd save data to let future generations know what we were thinking. Right? It was all historical. Now that's changing. Right? And the promise of big data is to drive future decision making. That if you have enough data, you can figure out what to do in the future, not just what you did do in the past. Right? That's what big data promises. Now, all of this data is surveillance data. And that's, I think, a very important thing to understand. And if you remember 2 years ago when we had the first Snowden stories, the refrain from the United States government was that it's only metadata. And by that, they meant it's not the conversations you're having, it's data about those conversations. Now, that's a very odd distinction. Right? To us programmers, it makes even a little less sense. Right? We know metadata is the data that a program needs to operate. But one program's data is another program's metadata. Right? So metadata is very much a relative and fluid definition. But in the popular press, in the popular culture, this metadata is data about the conversations. And I argue that metadata is fundamentally surveillance data. Right? So think about it. Imagine I hired a private investigator to put this guy under surveillance. To eavesdrop on him. Let's do that first. Right? And my investigator would put a bug in his car, in his home, in his office, and I would get a report of the conversations he had. Right? That is what the US president said the NSA is not collecting. That's the data. Right? Now imagine I hired the same private investigator to put this guy under surveillance. Right? I would get a different report. I'd get a report of where he went, who he spoke to, what he purchased, what he did. If you think about it, that's all metadata. Right? The data, the conversations is eavesdropping. The metadata, the actions, is surveillance. And what we've learned in the past 2 years, although we really kind of knew it before and didn't really think about it, is that metadata is a lot more important than conversation content. Right? It tracks our relationships, it tracks our associations, it shows what we're interested in, it shows what's important to us. It really reveals who we are. Right? Metadata is fundamentally intimate. Right? No one here lies to our search engines. Right? I mean, I hear some snickers, but that's really very true. Right? Our metadata reveals very intimate things about us. And it's also easy to store, easy to search, easier to analyze. It's easier to deal with in bulk, which is why it's so valuable to both governments and corporations. And right now, we're living in what I think of as the golden age of surveillance. Surveillance is everywhere. And it has a bunch of characteristics. It's incidental. This surveillance is a side effect of the things we want to do. It's not something that's separate, but it just happens incidentally. Right? We use our computer and generate surveillance data. We use our phones to generate surveillance data. It's covert. Right? It's not obvious. And if you were browsing the internet and you saw 10 people behind you staring at what you were doing, you'd say, hey, what are you doing? Get away. Right? But if you have 10, 20 internet trackers sitting in your browser doing the same thing, you don't notice it. Right? You don't notice the cell phone tracking. You don't notice the email tracking. We don't notice those things. We don't notice the cameras. It's also hard to opt out of. This is actually very difficult because a lot of this stuff comes from willing bargains we make with Google, with Facebook, with other companies. But truly, it's hard to opt out of it. It's hard to say to someone, if you don't like it, don't do it. Right? Don't have a cell phone, don't have a credit card, don't have an email account, don't have a Facebook account. Right? These are the tools of modern social living, and opting out is expensive and in some cases prohibitory. You can't live without an email address anymore. Well, you can, but you're kind of weird. And it's ubiquitous. Right? It's happening everywhere because everything is computerized. And ubiquitous surveillance is something new. It's something different. We're all used to surveillance. Right? We see it on television. Follow that car. And we got that. That makes sense. Ubiquitous surveillance is follow every car. And when you can, follow every car. Monitor every conversation. Right? Watch every person. You can do different things. It makes surveillance different. Right? So for example, you can do surveillance backwards in time. Right? Tell me where that car was last month. Tell me who he called last year. Right? Your limit there is just the size of your database. However long a buffer you can store you can query backwards in time. And depending on who you are, you're the NSA, you're Google, you're someone else, you'll have different size buffers for different kinds of information. You could do things like hop searches. Now, we saw this in some of the NSA documents, and you might have heard some of these stories about where the NSA makes 2 hops or 3 hops. So what this means is, and it's kind of interesting, that if someone is interested in you, they will look at you, who you talk to, that's 1 hop, who they talk to, that's 2, and who they talk to. Right? This ever-increasing cloud of communications links. And why is that interesting? It's interesting socially. It turns out if you follow 3 hops, you get a lot of extraneous noise, right? Everyone calls the pizza delivery place. But you also get loops. You see where there are social nexes, groups. You could learn a lot about people by following these hops. That's why you'll see things on Facebook where, if you ever do Facebook ads, you can show ads to friends of people who are friending your page. Right? That's a way to get a couple of hops away to new people who might be interested in you who don't know about you. Right? That's a kind of hop analysis. Or about searches. We know the NSA does some of this, where instead of searching for a person, you search for a word or a topic. Find me everybody who's talking about this. Right? And you need ubiquitous surveillance to make that work. Or find me a person that meets certain characteristics. This was a Canadian document we saw out of the Snowden archives, and it's kind of interesting story. They had a whole kidnapping story around it, but basically they were looking at the cell phone location data for basically timestamps, time location stamps. Right? Find me a person who is here on this date, here on that date, and here on that third date. And you can search the metadata and find the 1 person, the 2 people who met those characteristics. Right? Or flagging something as interesting based on predefined characteristics or just based on not being normal. And once you have all the data, you can figure out what's normal and what's not normal. Right? Now, of course, this analysis isn't possible without ubiquitous surveillance, and it isn't possible without computers. Right? People don't do this, computers do this. And I think in the debates about surveillance, we have a very human-centric view of how things are done. And a lot of people don't realize what happens when a computer does it. So this data is largely being collected and largely being used by corporations. Right? We know this. Surveillance is the business model of the internet. We build systems that spy on people in exchange for services. Right? This is Facebook, this is Google, this is pretty much everybody. Now, we originally did this for efficiency reasons. Right? Back in the early days of the web, there was no obvious way to charge for services. People expected the net to be free. There wasn't the ability to take micropayments. So the only obvious revenue model was advertising. There was also a side, especially in the United States, a huge data collection industry, data brokers. And this led to sites that basically make their money spying on you. Right? There's a phrase maybe a dozen years old that if you're not the customer, you're the product. And it's important to remember that if you're not paying for the service, you are the product. And actually, for most services now, even when you are the customer, you're still the product. And a lot of the stuff we buy also spies on us. I mean, I think of these drivers as free and convenient. These are the drivers of corporate surveillance on the internet. Now, the data is collected, I just said that a second ago, for the purposes of psychological manipulation. That's why we're doing it. We call it advertising, which is the other business model of the internet. Right? Convincing you to buy things you might not want to buy otherwise. And in this system, more data is more power and more revenue. Personalized ads, personalized offers, personalized manipulation. So there is this rush to get more and more data about us, more and more surveillance data. You know, and corporations know an amazing amount about us. It really is almost staggering when you think about it. Right? You know, our cell phones, this is probably the most effective surveillance device ever invented. We don't think of it that way. But this knows, I mean, just location data. This knows where we are at all times. Knows where we live, knows where we work, knows when we wake up in the morning because it's the first thing we check, knows when we go to sleep at night because it's the last thing we check, knows who we sleep with because you both got one. Right? Remember, incidental. In addition to our text messages, our searches, our browsing, everything else we do. I used to say that Google knows more about me than my wife does. Right? It's actually true, but I could go further. You know, Google knows more about me than I do. Because Google not only knows everything I think about the moment I think about it, because yes, but Google remembers it forever, and I don't. Like, Google knows what kind of porn all of you like. It does, and that's a little creepy because I don't want to know. So government surveillance is largely piggybacked on all of this. And we saw this from the NSA documents. They use internet cookies and logins and cell phone location data and all of those things. Right? They just collect what is already being collected. And this lets governments get away with a level of surveillance we would never allow otherwise. Right? We would never carry a government-issued tracking device, yet we all happily carry one of these. You know, we would never alert the police when we made a new friend, but we happily alert Facebook. Right? We would never agree to have the government keep a copy of all our correspondence, but it's all in Gmail. And so all governments need to do is get themselves a copy. And how they get a copy depends. Right? In the United States, there are legal mechanisms by which the NSA will get copies of Americans' data. You guys are all open season. Right? Government of China, seems to be happy to break into people's networks and grab data. Right? Other governments do different things. And what's interesting is that data quality matters here, and it's different. For the purposes that the data is being collected, it doesn't have to be very good. Right? It's being collected for advertising. I mean, right now, advertising is lousy. You go outside, you see a billboard, and most people who see that billboard don't care about it. So if you can collect data to have your advertising be, twice as effective, let's say it only has a 30% error rate, that's fantastic. But for government uses, right, if you're like dropping a drone on somebody, you kind of want more accurate data. Right? So watch data accuracy because that changes. Now, most government surveillance happens because of fear. Right? Fear is the driver of government surveillance. Right? I mean, in the past 10 years, it's fear of terrorists. Before that, it was fear of criminals, of kidnappers, of drug dealers, of whatever the internet bugaboo was back then. In some countries, it's fear of dissidents, fear of new ideas, fear of rival political parties. And again, data equals power. Now, the nature of government surveillance, I'm going to use the NSA as an example, but I'm really more general. The nature of NSA surveillance changed around the same time we started producing all of this data exhaust. And to understand the NSA, you need to understand the NSA's history. NSA was born during the Cold War when a voyeuristic interest in the Soviet Union was normal. Right? That was what we did. We collected a lot of data on the Soviet Union, on the Warsaw Pact, on Communist China. Right? Some of it useful, a lot of it not. It's much easier to learn, I don't know, for the speed of the new Soviet main battle tank than it is to predict the fall of communism. Right? Facts are a lot easier to eavesdrop on than ideas. And that kind of surveillance started to wane after the fall of the Berlin Wall, after the fall of communism. And there was a lot less of it going on. And that surveillance got a new lease on life after the terrorist attacks of September 11th. Right, after those attacks, the U.S. intelligence community got an impossible mission. Never again. And if you think about it, well, one, that is an impossible mission. But if you have that goal of making sure something never happens, the only way you could possibly do that is to know everything that does happen. And the only way you can do that is through ubiquitous surveillance. Right? And when the enemy, who used to be those guys over there, becomes anyone anywhere, you need to watch everyone everywhere. Right? So the NSA changed. Their mission changed from espionage to surveillance, and from targeted surveillance to ubiquitous surveillance. So that giant laser-focused eye on the Soviet Union became this all-seeing eye on everybody. At the same time, the nature of our communications changed. Back during the Cold War, you would spy on specific communications links. So you might spy on, I'm making this up, a military communications link between Moscow and Vladivostok. And the neat thing about spying on that link between Moscow and Vladivostok, that you'd only get Soviet military communications. You would never get chatter between, individuals living in the United States on that communications line. That, of course, is different now. The internet doesn't work that way. Right? There are no longer separate communication links for different communications. We all run on the same internet. It is global. It is ubiquitous. It is everywhere. And it's very possible, right, that if you here in Oslo are talking to somebody in Tromsø, that your communications gets routed through San Francisco. Right? That wouldn't even be unusual. So now you can't separate communications by their physical links because it's all virtual. At the same time, we're seeing more power in IT companies. And there are two trends I want to talk about here. The first is the rise of cloud computing. Basically means we no longer have control of our data. Our data is no longer on our computers. Maybe ours, but we are exceptions. Right? For most people, their data is on servers elsewhere. Email, photos, calendar, address book, messages, documents. Right? They're on servers belonging to Microsoft and Apple and Google and Facebook and everybody else. Right? Their data is not on their computers. Second trend is that people are increasingly accessing data using devices they have much less control of. Right? Computers are becoming a minority, general purpose computers. These things, iPhones, iPads, Android phones, Kindles, Chromebooks, all of those tethered devices, much more controlled devices, are becoming the norm. Right? People are using those rather than general purpose computers. And even watch the computers. Look at the current OSs. Windows 8, Apple's Yosemite. I mean, they all are moving towards more vendor control of the configuration, of the system, of the software. Right, this is all possible, of course, because these devices are always on the internet. Now, we're seeing in the United States a lot more wireless and cable monopolies, giving vendors more control. DRM, digital rights management, we're seeing become more ubiquitous, different countries, again giving more vendor control. Now, these all matter for surveillance. People have much less control over what's being monitored here, and people's data is now being controlled by third parties. This is the whole debate in the United States about PRISM. You know, when the government wants to search, well, not my email, someone's email, they don't have to ask them anymore. They just have to ask Google. Right? I'm probably the last Eudora user on the planet. Well, probably in this room there are a few, but we are still a minority. So what we're seeing here, I think, is a very robust public-private surveillance partnership. We see governments leveraging data corporate collection everywhere. In the United States, at least, other countries as well, corporations mining government databases. An enormous number of private corporations support government surveillance. Government contractors, surveillance technology partners, cyber weapons arms manufacturers, an entire security industrial complex. I mean, building these systems that governments use. And it goes very deep. You know, we've seen some breaks in that, especially in the United States, sort of interesting to watch. I mean, U.S. companies are demanding more transparency. There are laws preventing U.S. companies to talk about government surveillance, and companies are working to change that. More U.S. companies are fighting secret national security letters. And if you know, right now, there's a case going on where Microsoft is fighting a U.S. government order to turn over data that resides in a server in Ireland. And there's a question of sovereignty there. So why does this matter? I mean, I spent a lot of time on this. Let me talk a bit about why this matters. I think this is extremely important. Right? It's important for political liberty and justice. You know, we're now living in a world where people can be accused by their data, right? Where their data can find them guilty of something. You know, we are seeing censorship based on surveillance. In many countries of the world, we are seeing people arrested based on surveillance. And as a result, we're seeing an enormous number of chilling effects, that people are not talking about things. Robust research in the United States that people were searching less on controversial topics after September 11th and after the Snowden revelations. Right? This kind of surveillance inhibits dissent, inhibits social change. Coming with it is the secrecy creep. There's an enormous amount of secrecy in most governments about this sort of surveillance. US, UK, EU countries, Australia, with the kangaroos we see around everywhere. There's a lot of secrecy. And there's abuse. Not a lot, but some. You know, in some countries you could say it's all abuse. But there are very strong reasons why governments shouldn't have these broad powers of ubiquitous surveillance. Right? There are problems with commercial surveillance, of fairness and equity. We are seeing surveillance-based discrimination. Right? People are being discriminated against, put in different categories, and treated differently based on surveillance data. We are seeing people being manipulated based on surveillance data. And we're seeing, if you follow the news the past couple of weeks, an enormous number of security breaches, right? Privacy breaches. That when you have this surveillance data all in one place, it is a very rich target for criminals who want it. And again, you know, in the United States, we saw payroll data, we saw health data, lots of financial data, right, being stolen. There are strong business competitiveness reasons why this matters. And we're seeing some data out of the United States about how NSA surveillance hurts U.S. products and services. So all you non-U.S. people not buying them, good for you, right? Because this is pressure for change. But I think, you know, government and corporate surveillance both hurt the purchase of products. Right? And there's security reasons. Right? This infrastructure of surveillance does hurt our security. All right, how do we fix it? I mean, what do we do now? And this is really where I think all of us, you know, actual coders and developers, really have to start thinking together. Because we are the people who will implement any of these fixes. Now, a lot of the fixes are more societal than technical. But first, there's a conceptual change. We need security and privacy. You'll often hear lots of debates about security versus privacy. It's if you can choose one or the other, that if you get more of one, you get less of the other. That's absolute nonsense. Right? Privacy is a part of security, and security is a part of privacy. That we need both together. And the way to think of this is remember that there are many different adversaries operating at the same time. That it's not security against the terrorists or privacy. That it's security against everybody. The terrorists, the criminals, the governments, each other, the corporations. And to get that, we need privacy. That we're constantly balancing amongst many different threats. I think this is a subtle point to make on television, but something that's kind of obvious in this room. And once you realize that security and privacy are required, you start understanding very quickly that we need to prioritize security over surveillance. Right? That security for all of us is more important. Right? That we need to build our systems to be secure rather than build our systems for surveillance. So I'll talk more about that later. We also need more transparency. Right? Transparency is extremely important. The culture of secrecy means these things are not discussed in the open. They're not debated. Right? The United States actually has secret orders based on secret interpretations of secret law, which is kind of weird, but it is where we are. So we need openness. Now, the idea was behind the secrecy is that you could have a secret few be a proxy for the many. Right? So in the United States, there were a few congressmen who knew about these programs. Right? They were cleared, they were read in, and the idea was because they were of both parties that they would be a proxy for the whole body. And you wouldn't need to tell everybody, you can tell the few. Right? That model, that proxy model, really has been shown to fail. I mean, it doesn't work. Right? Since the Snowden forced the NSA actions into the public, we've seen the executive of the United States, the legislature, and judiciary all change what they were doing, change their opinions. Right? The notion that you could have a secret court as a proxy for the open court, or a secret subset of the presidency as a proxy for the whole thing, that all fails. I mean, it doesn't work. So we actually need transparency, both in government and in corporations, to know what's going on. Right? Transparency isn't enough. You need oversight, you need accountability, you need the next steps, not just knowing what happens, but understanding it and holding people accountable when they do things wrong. I mean, these seem like all reasonable algorithmic solutions to the problem, but they're hard to do politically. The next principle is that there's only one world. I mean, I think of it as one world, one network, one answer. That this notion that we could secure our stuff and spy on their stuff doesn't work. Either there's security for everyone or security for no one, and either everyone gets to spy or nobody gets to spy. So I don't know, I assume people have heard of stingrays. We hear a lot about the United States. I'm reading articles about the UK also. Other countries have them. Basically, this is an IMSI catcher. A stingray is a fake cell phone tower. And you can put one up, and governments do, the FBI does, and other countries, and they can do that to figure out what phones are right here, or to eavesdrop on calls right here. Very localized cell phone surveillance. A stingray is actually a trade name. It's a Harris Corporation product. There are a bunch of different products, but stingray is what the press has glommed onto, so that's what they're kind of all called. Now, the thing about stingrays is they are a very secret government technology. In the United States, the FBI is scarily secret about this. They will swoop down and grab documents, and they might become public. They've dropped cases in court rather than letting evidence appear about stingrays. They're really secret. Now, except they're actually not really secret. I mean, at DEF CON a few years ago, someone built one and demonstrated it. Right? You can go on Alibaba right now and for $1,500 buy yourself basically a Stingray. They are used for, in China, and I'm not making this up, to send SMS spam. Right? They're everywhere. They're not secret technology. And in fact, last year, one of the internet magazines went around Washington, D.C., and found dozens of Stingray devices around government buildings, around embassies, run by we have no idea who. Right? Either we design the cell phone system so that there's authentication in the handset tower link and Stingrays can't work, or everybody gets to use them. Right? Either everybody gets a spy or nobody does. You know, we saw the same thing with quantum. I don't know if people remember quantum. Back 2 years ago when I was working with some of these Snowden stories, the one thing that the NSA didn't want revealed was a program called Quantum. Quantum is their packet injection program in the middle of the internet. Right? Very secret, very impressive, worth looking at. Turns out if you can do packet injection in the backbone, you do a lot of really neat things. And this was their secret technology, except that it actually wasn't. You know, there's a hacker tool called AirPawn that lets you do this. A few months ago, I saw basically building quantum assigned as a grad school homework assignment in a computer science class. Right? That these things become democratized. China uses quantum, basically the same technology, in their Great Firewall of China and in their Great Cannon. Right? So either we build encryption authentication into the backbone, which will prevent anybody from using this, or everybody can use this. Right? Those are our choices. All right, so there are political, legal, and technical solutions here. And they have to work in tandem. The problem is that we're living in a world where law can subvert technology and technology can subvert law. Right? We can design the best security protocol, then the FBI goes to Microsoft with some kind of court order and makes them break it without telling us. Right? Or you can have two caffeine-fueled MIT undergrads designing an encryption program that defeats surveillance. So both have to work. Right? So we have, we really need to think about it in tandem. I have a bunch of examples I talk about in writings. I'm going to give 3 examples of what I think are solutions here. One is to separate espionage from surveillance. That right now in the United States, they're all considered the same thing. But really, targeted espionage against governments, I think, is fundamentally different than broad surveillance against populations. Right? One is military, the other is more law enforcement. So a legal separation can be very valuable. And that really is a legal solution. I also think we need comprehensive data protection laws. Right? Europe's better than the US here. The EU has some good data privacy laws. The United States needs better data privacy laws. But things like that will protect our data from this corporate collection in the first place. And ubiquitous encryption is another example. The more we encrypt, the better we are, the safer we are. And this is actually an important point. Encryption isn't a panacea. Right? If the NSA wanted into your computer, they would be in your computer, period. Done. Right? If they are not in your computer, one of 2 things is true. One, it is illegal and they've chosen to follow the law. And 2, you're not high enough on their priorities list. Right? What encryption does is it forces the listener to target. I mean, to me, the biggest revelation from the NSA stories is that the NSA is not made of magic. Right? They have a bigger budget than all of us combined, but they are still constrained by the same laws of physics, of math, of economics as everybody else. And what encryption does is it leverages those laws. It prevents the listener, whoever it is, from eavesdropping on everybody and forcing them to pick and choose. We have a much harder problem after that, right? Our computer security is so bad, our endpoint security is so bad, that we really can't protect individuals who are targeted by major governments. But we can protect the masses. And we do that through encryption. The more encryption we put in the backbone, we put in the protocols, we make ubiquitous, the safer everybody on the planet is. And this is enormous. Now, before any of this can happen, we need social change. But right now in the United States, there is a fight over encryption, where the U.S. government is, still in the background, starting to make demands that any encryption come broken, right? That it not be good, that it be breakable if the government demands it to be broken. Right? Weird request, as developers, we know we can't do this. I cannot write a piece of software that operates differently when a certain piece of paper is nearby the computer. Right? That makes no sense. Right? Really what I'm being asked to do is build a social system on top of a technical system, and once you think of it that way, suddenly the problem gets obviously much harder. But we do need social change, right? We need to get over our fear. I think some of that's happening. We need to value our privacy. Some of that's happening. There's some recent surveys on privacy. There was a Pew Research survey, which is the United States only, that really showed very conflicting views on privacy. Depends how you ask the question, depends who you ask, but about 50-50. Certainly I think an enormous change from 10 years ago. There was another survey last November, much more international, from about 20-something countries, that looked at how many people knew about Snowden and made changes in the way they use the internet based on that. And when I read the survey didn't do the math, but I did, and I found that 700 million people worldwide have taken steps in the previous 12 months to avoid government surveillance. Now, that's an extraordinary number. It's probably a weird statistic. I mean, probably most of the things those people did weren't effective, and maybe some people sort of wanted to do things but didn't, but self-reported otherwise. But even so, I can't think of another issue anywhere where 700 million people on the planet changed their views in 12 months. And so this is a political issue. And this is a very important issue. And let me make this issue more general, because this is not just a security conference. The question really is, how do we design data systems that benefit society as a whole while at the same time protecting people individually? And I maintain this is the fundamental issue of the information age. This is the issue that we will be debating this year, next year, in 10 years, in 20 years, in 50 years. Right, so here it is. Our data has enormous value to us collectively. Our data has enormous value to us individually. How do I extract that collective value while maintaining the individual value? Right? It's data in the group interests versus data in the individual interest. It's the societal benefits of big data versus the individual risks of personal data. And we see this again and again, right? In movement data. I mean, I use Google Maps when I'm driving in the United States, and I get a lot of benefit from the fact that Google Maps shows me real-time traffic data. It shows me where the traffic jams are. And it shows me that because everybody using Google Maps is under surveillance, and Google knows how fast we're all going. Right? Incredibly valuable to the group, yet incredibly personal individual. Right? Behavioral data for advertising gives us all of these free services, gives us ads we actually sometimes care about. You know, I think one of the best examples is Amazon. When I go onto Amazon, I get ads for books I might want to read based on books I've purchased. And I find some really good books that way. Right? So there's enormous group interest in that data, yet it's incredibly personal. Right? Or take this government surveillance data. I mean, if you take the NSA at its word, what it's saying is, we need all of your data to keep you safe against terrorism. Right? We can argue about the efficacy, but that's the basic trade-off they're asking us to make. Give us all your data, and it will be valuable to you as a group, yet it's incredibly personal. Right? Or medical data. I think there is incredible value in everybody on the planet taking our medical data, putting it in one big database, and letting researchers at it. I think the value of that will be extraordinary. Yet, wow, that's kind of personal and scary. We're going to see these debates over and over again. They're going to be tied to the actual data, to the application, to the use, to the time, and we're going to make different decisions in all those different circumstances. And we're going to make them again and again. I started by using the phrase data as exhaust, that we all leaving data exhaust everywhere we go. And I want to take that analogy further. I think data is the pollution problem of the internet. I mean, think about it for a second. All processes produce it. It stays around, festering. What we're talking about here is how we deal with it, how we reuse it, how we recycle it, who has access to it, how we dispose of it, what laws regulate it. And this is central to how the information age functions. And I believe that just as we look back today on the early decades of the industrial age and wonder how the titans of industry could have ignored pollution in their rush to build the industrial age, I think we too here will be judged by our grandchildren and great-grandchildren, here us in the early decades of the information age, on how we dealt with data, right? How we rebalanced power that resulted from this new data, how we disposed of it, used it, reused it, regulated it. This is our pollution problem, and it's going to be around for decades. Thank you. Oh, there's flowers, oh my heavens. Hey, thank you. And I can bring these on airplanes.
And that's the gift we do to
So I think this is the best speaker's gift ever. I know people know about this. Instead of giving me something I actually don't want, they are donating money to a charity. So I mean, these guys are great, and I think everybody should do this at any running conference. There's a couple of things. I do have a book. I brought some with me, not a lot, but I'll be down there. So if anyone wants one, grab it. I also have a book flyer. This is the thin version of the book. Right? It has the same cover, but far fewer words on the back. So feel free to grab one of those. I'll be down there in that corner, happy to take questions. Enjoy your conference. Enjoy Oslo. Enjoy the fact that it never gets dark. Thank you very much.